students. Today we will come to the next portion, that is transformation of energy. So you please refer your book, page number 53, 54 and 55. So we will discuss today about the transformation of energy and the law of conservation of energy, and also the conservation of energy in a simple pendulum as well as in a roller coaster and hydropower plants. And the last topic we will discuss it about the power. So from there we will come to the end of the chapter. So now let us come to the transformation of energy. The first point we will discuss it about the transformation of energy. Now there are various forms of energy. Like in class 7 you have studied about the different forms of energy, like the heat energy, light energy, sound energy, electrical energy, mechanical energy, chemical energy, okay, nuclear energy. So many forms of energy are there. And these forms of energy can be transferred from one form to another. Always the transformation of energy takes place. And the energy, you cannot destroy it, nor you can create it. You cannot create energy, nor you can destroy it. But this energy can be transferred from one form to another form. And this transformation of energy is given, the energy which can be transferred from one form to another is given by a law known as the law of conservation of energy, which states that energy can neither be created nor destroyed, but it can be transferred from one form to another form. Or in another way also we can state the law, that is the sum total of energy. The sum total of energy of different kinds of energy, the sum total of different kinds of energy in an isolated system remains constant. That means whatever the different forms of energy are there, like light energy, sound energy, heat energy, chemical energy, kinetic energy, mechanical energy, okay. So these different forms of energy which are transferred from one form to another, when the transformation of energy takes place, the sum total of energy remains constant. Okay, so I'll give you one example. Like let us consider the energy which are stored in a vehicle. In a vehicle, the chemical energy is stored on it. And later on, this chemical energy will be converted into mechanical energy. Also, the energy which are stored in a water, which are stored in a height or in a dam, the energy which are stored in a water is gravitational potential energy. And when that water is allowed to flow, the gravitational potential energy will be converted into kinetic energy. Likewise, electric bulb, the electrical energy will be converted into light and heat energy. In a microphone, the electrical energy will be converted into sound energy. Okay, and in a microwave oven also, the electrical energy will be converted into heat energy. So that means here what happens is different forms of energy are converting from one form to another. And all the body have got energy stored on them. Every object have got energy stored on them, and that energy can be converted from one form to another form, which we call it as a transformation of energy. Okay, so when the transformation of energy takes place, one form of energy will be converted into another form, which is stated or given by a law known as the law of conservation of energy. And now this law of conservation of energy is demonstrated, okay, by one experiment, okay, and this experiment is based on the pendulum. So according to the law of conservation of energy, the sum total of energy, when there is a conversion of energy from one form to another, the sum total of energy remains constant. So let us consider one example related with a pendulum. Okay, now how the energy changes in the pendulum, and when the change of energy takes place here, the sum total of energy remains constant. Now let us consider this, follow this diagram here. This is a pendulum. Okay, a pendulum consists of a metallic bob. This is the bob. Okay, which is suspended by a rigid support. Okay, and has a light and rigid string. Okay, this is a light and rigid string. So that means this pendulum, now this pendulum is supported by, it is fixed at a rigid support. Okay? This is the rigid support, and it has a long string here, and this string is light and rigid. And this string, on this string, at the lower portion of the string, there is a metallic bob. We call it as a bob. This is a spherical body. Okay, round body is here, which we call it as a bob. Now, this pendulum will have motion, which we call it as oscillation. When the pendulum will swing, the pendulum swings to and fro. To and fro means it moves towards right, again it comes back, then again it moves towards left, again it comes back. So that means they move to and fro. To and fro means it goes forward and backward. Okay, so this pendulum, they keep on swinging. And when the pendulum is at rest, when the pendulum is not swinging, when the pendulum is at rest, and let us consider the pendulum which is at rest is at the middle, is at the center. So A is the position of the pendulum initially, when the pendulum is not swinging. Okay, when the pendulum is not swinging, the pendulum is at rest here. Okay, so rest means that is at the mean position, we call it. Now from the position A, now when the pendulum will swing, when you give a small push to the bob, this pendulum will start moving, and they will start oscillating, and that to and fro motion is known as oscillation. Okay, now at the mean position of the pendulum is at A. From the position A, you will slightly apply the force, slightly push it. When you push it, what will happen? The pendulum will come in the state of motion. So when the pendulum will come in the state of motion, now the pendulum will start swinging. Okay, so this pendulum will swing and it goes up to B. Okay, and this B is known as the extreme position. Extreme position means from this point B, the pendulum will not swing further. It will not go. This is the extreme position. So at the point the pendulum can swing up to a distance of B. So that means it can come to this position B. Then again, when the pendulum again goes back towards the left, it goes towards C. Okay, and this C is also the extreme position. So B and C are the extreme position of the pendulum, and A is the mean position of the pendulum. So now what happens is, now let us find the energy change, the change of energy in the pendulum. Okay, now from the position A, now the pendulum will start swinging. When the pendulum will swing, the pendulum comes in a state of motion, and the pendulum will possess kinetic energy. The pendulum will possess kinetic energy. So that means since the pendulum starts its motion from the position A, so at position A, the pendulum will have what? Maximum kinetic energy. At the position A, the pendulum will have what? Maximum kinetic energy. Now this pendulum starts moving, it starts swinging, and it goes towards B. Okay, and again another point I have made here, that is D. In between A and B, another point I have made here, D. Now when the pendulum will swing, this pendulum will raise to a height. It goes up. So when it is swinging, what will happen is that now at the position D, the pendulum will possess both kinetic energy and potential energy. It has got both kinetic and potential energy. Now why it happens is that since the pendulum is swinging, it is in motion, kinetic energy, and pendulum is going towards height, it is raising towards the height. So when the body is raised to height, you know that the body possesses gravitational potential energy. So at the position B, the pendulum will have both kinetic and potential energy. And finally, when the pendulum will come towards B, that is at the highest point or at the extreme position, the pendulum possesses only potential energy. That means the potential energy will become maximum here. Okay, so these things will take place same thing. The same procedure will follow from A to when the pendulum swings from A to C. Now, from A, now at the position A, at the mean position, the pendulum will possess kinetic energy, that means only kinetic energy, or the kinetic energy is maximum at the position A. When the pendulum will start swinging, okay, the pendulum will possess both kinetic and potential energy. Then when it starts swinging, the kinetic energy, the pendulum will have kinetic energy also as well as potential energy also. Okay, since the pendulum is raising to a height. And here and this, and from the position A, when it goes towards right, what will happen is that the kinetic energy will be changes into potential energy. Though the kinetic energy is here, but the kinetic energy slowly what will happen? It goes on decreasing, potential energy goes on increasing. Okay, though the kinetic energy and potential energy is here, but the kinetic energy is less. Okay, when it goes towards the height, the kinetic energy decreases, potential energy increases. And at the extreme position, the potential energy becomes maximum, the potential energy will become more, and the kinetic energy will become zero. So that means at position B, the kinetic energy will be zero, the pendulum will have only potential energy. Now again from B, the pendulum will again, it has to come back. Okay, it goes towards B, again it comes back. When it comes back, again what will happen? At the extreme position, potential energy is maximum, kinetic energy is zero. Then from B, what will happen when it comes towards D? The pendulum will possess again both kinetic energy and potential energy. But from here, the potential energy starts converting into kinetic energy. Okay, or the potential energy when it comes towards A, the potential energy decreases, kinetic energy increases. And finally, at the position B, the pendulum will have both kinetic energy as well as potential energy. But what will happen here? The kinetic energy increases. When it comes down, kinetic energy increases, potential energy decreases. And when it comes at the position A, potential energy completely becomes zero, and the body possesses only kinetic energy. So same thing when it goes towards C, from A to C when it goes, from A also the kinetic energy, and position E, both kinetic and potential energy. Why it happens, you know that. Okay, since the pendulum is raising towards the height and the pendulum is moving, so at the position E, the pendulum will have both kinetic and potential energy. And at extreme position C, the kinetic energy will be zero. The pendulum will possess only potential energy. Again, when it comes down, the potential energy will be converted into kinetic energy, and when it comes at the position A, the pendulum will have got only kinetic energy, no potential energy. So therefore, when we consider this example, at the extreme position, no kinetic energy will be zero, but the pendulum will possess only potential energy. At mean position A, the pendulum have got only kinetic energy. So therefore, from this example, what you will observe is that the transformation of energy is taking place. Okay, there is a transformation of energy. You cannot create energy, nor you can destroy it according to the law of conservation of energy, but this energy can be transferred from one form to another form. So this example shows that when the transformation of energy takes place, the sum total of energy remains constant. That is, the sum of kinetic energy plus potential energy remains constant. So this verifies. Okay, this experiment shows that this example shows that the pendulum, when the pendulum swings, there is a change in the energy, there is a transformation of energy, and that energy remains constant. Okay, and the next one is the transformation of energy in roller coaster. Now, roller coaster, Okay, now you may have a ride in a roller coaster. It goes that a ride is there, a car is there, okay, and this car will start moving from the ground level towards the height. Okay, and from the height again it comes down. So that means it moves up and down like this, up and down it moves, roller coaster. Okay, so it's quite exciting this one game. It's a kind of a ride, exciting ride, thrilling ride. Okay, so you can in roller coaster also there is a transformation of energy. So how it happens is that now you can find this roller coaster when we go to Rhenock. Okay, in our science center is there. You can one day those who have not been, those who have not have a ride on this roller coaster, you can go Rhenock and visit that place. You will find the roller coaster. So in a roller coaster, you ride in the roller coaster. So this roller coaster, first what will happen? This roller coaster is at the ground level. You just sit on the car, and this car will slowly starts moving up. When the car will start moving, the car will possess only kinetic energy. Now this car will start moving up to height slowly, and the speed will decreases, and this the car will pulled up. It is pushed up or pulled up with the help of a motor. And slowly what will happen when they start increasing, rising towards the height, the kinetic energy start changing into potential energy. That means the kinetic energy decreases, potential energy will go on increasing. And at a certain height, when they reach to an extreme height, the kinetic energy will completely become zero. The car will possess only potential energy. Now from that height, the car will rush, or they will move at once down with a greater force. Okay, and there you will have some thrilling experience. At once the car will move down. Okay, and it has a sloping surface. It moves down. So at the topmost height, the car will have only potential energy, and from the height when the car moves down, the potential energy will be converted into kinetic energy. Okay, and finally the kinetic energy, and finally the kinetic energy goes increasing, and when it comes down, then totally the potential energy becomes zero, and therefore the car will have got only kinetic energy. So here also the roller coaster, the kinetic energy, there is a transformation of energy from kinetic energy to potential energy. Another example is hydro power plant. So a hydro power plant is generates electricity. Now first of all, the water is stored in a dam. The water which is stored in a dam possesses potential energy, which we call it as a gravitational potential energy. That means it has been, these water are stored to a height, to a certain level, to a certain height. And the energy which is stored in that water in a dam is a gravitational potential energy. And once that water will start flowing, the flowing water, now when the water flows, the gravitational potential energy will be converted into kinetic energy. And when the water flows, the force of that water, since the water exerts pressure, you know that. So the force and the pressure of the water will help to rotate the turbine. Okay, and these turbines are again connected with the generator. This running water will rotate the blades of the turbine and the generator, and these turbines are connected with the generator, and therefore the running water, the flowing water will produce or generate electricity. So therefore, now what happens here? Potential energy to kinetic energy, and kinetic energy again to mechanical energy. Mechanical energy means that is you can see that the blade of a turbine will start rotating. They will do some mechanical work. Okay, some work is done. So in every case, even in this pendulum, in a roller coaster, in a hydropower plants, work is done. Okay, and when the work is done, some form of energy is getting transferred towards the another form. So therefore, in a hydropower plants also, what will happen here is that now the running water will rotate the turbines. Okay, and these turbines, when the turbines will rotate due to the rotation of the blades of the carbide when it rotates, and that will produce electricity. So therefore, this example also shows that when the energy transformation takes place, the sum total of energy always remains constant. So this is about the transformation of energy. And the next one, the last point, will come to the power. Now the power is defined as the rate of doing work. P equals to W divided by time. Power, to calculate power, work done divided by time. So when we define power, power is defined as the amount of work done. It is defined. Power, the work done in a unit time is known as the power. Okay, so when we define power, work done in a unit time is divided by time. Work done in unit time is known as power, or power is defined as the work done per unit time. Okay, and now this power, now when we do work in a short time, when we do any kinds of work, okay, and to do that work, when you need less time, then the power which you spend will be more. Okay, the power will be more. Remember that the power will be more when you do any piece of work in a short time. When the time taken or when the time factor is less, in a less time, when you do more work, then the power is considered as more power. Okay, and if to do a small piece of work when you take more time to do, then the power is less. Okay, so power depends upon in how much less time you can do a large amount of work or any kind of work. When you perform any kind of work in a less time, then the power is said to be as a more power. So the SI unit of power, let us come to the SI unit of power. The SI unit of power is watt. W-A-T-T. The SI unit of power is watt. Okay, now let us consider that now the SI unit of watt is joule. SI unit of time is second. Okay, so and instead of power, what I write, I'll write watt. W. And watt can be written as capital W. The symbol of watt is capital letter W. So now you can define watt also. Define watt. Now how you define the watt is that now I write 1 watt, 1 joule, and 1 second. Now 1 watt, the power is said to be 1 watt if 1 joule of work is done in 1 second. So if 1 joule of work is done in 1 second, then the power developed is considered as 1 watt. This is the definition of a watt. Okay, and watt is the SI unit of power. And again, another high unit are here. Okay, which we call it as a horsepower. And this horsepower are used in mechanical engineering. And this horsepower is equivalent to 746 watt. 1 horsepower, it is written as XP, small letter x, small letter p, which is known as horsepower. 1 horsepower is equal to 746 watt. Okay, so 746 watt makes 1 horsepower, and this power is used in a mechanical engineering. So when it comes define horsepower, it is defined as it is the power which are used in mechanical engineering. So this is about the power. Okay, so and power is defined as the amount of work done in a unit time. So to calculate power, we have to divide work done by time. So what work done have to find? We have to find the work done. Without finding the work done, we cannot find power. So work done, when time is given, and when the work done is given, then we can find power. So power equals to work done divided by time. This is the formula to find power. As well as to find the work done equals to force into displacement. W equals to F into S. So this is about energy. So we have come to the end of this chapter. In the next class, we will start with another chapter that is related with light. Thank you.